Okay, good morning, everyone. Are we able to see the portion of the screen that I've got up here? And if I go over here, can we see the new screen now too? Awesome.
Yes.
I had not set up the multi-desktop display before, so I wanted to make sure we had that working nicely. All right, in that case, I'm going to go ahead and jump right into it. Thank you all for being here. My name is Kona Farry. I use he, him pronouns. And I'm coming to you today from the land of the Snohomish, Suquamish, and Stillaguamish peoples, known today as Everett, Washington. We're going to be talking about transit apps. I'm the developer of Pantograph, which we're going to take a look at today. We're going to look at what it is, how it works, and a lot of the open data that is behind Pantograph and most of the other apps that we interact with every day, and talk about how all of this is put together, how it works, the importance of all of it, and all that kind of thing. So I'm going to go ahead and jump right into it. This is the resume slide. I'm going to breeze through this in the interest of time, but just for a little bit more about me, I got my degree in community environment and planning and graduated in June of 2020, which was a fantastic time to be graduating, as you might imagine. And as of this past October, I now work at my local transit agency, Community Transit, as a schedule analyst. So my team helps build the schedules that our buses and our operators drive off of every single day. My role focuses very specifically on utilizing all of our various data products from our AVL system, from external sources, internal sources, to help build the best schedule that we possibly can. But today, I'm not speaking on behalf of my agency. I am focusing on my app and the things that I do with Pantograph. This was something that got started in 2018, kind of my late sophomore, early junior year of college. I wanted to supplement, I knew that I was going into transit professionally, and I wanted to be able to supplement that by doing some learning and research outside of my formal education. So that led me into GTFS, which I started learning as an opportunity to just kind of learn about how scheduling and operations work. And when I got into the real-time side of things, I knew that I was going to need some way to put that learning into practice. I couldn't learn that in the abstract. And so when I realized that those feeds could be used to create essentially a dispatch-like view, you know, like you're sitting in a control room and seeing the big picture of where all the buses are and what they're doing, that gave me what I needed to get going. So I had, at the time, no real experience with software development, but I needed to be able to make what I was trying to see. So this also became a way that I learned how to do software, on how to write code and that sort of thing, because I needed to be able to make an application. Ultimately, it ended up launching in March of 2019. I had kept polishing it to the point where it became something that was releasable, even though that wasn't my original intent. I was very fortunate to be able to announce it on the Seattle Transit blog, which is exactly what it sounds like. And from there, a lot of the local media picked it up. I did a number of TV interviews. It was on the Seattle Times. And there was a lot more interest in my little side project than I was anticipating. At the time, it was a little overwhelming, but in a good way. So today, after it launched, after the dust settled, I focused on maturing a lot of the infrastructure, because I had started all of this when I was a new developer and didn't really know what I was doing, and now had a little experience under my belt and knew what I was doing. I could see all the mistakes that I had made in implementing it the first time. So at first I just had to make sure that it was stable, and then I had to go back and essentially redo a lot of the work with the knowledge that I had. So that was a lot of the first year, even 2 years of Pantograph, was kind of this iteration, both in terms of features, but also in terms of just making sure that the backend is structurally sound. Today, when a lot of that work enables the ability to expand into other regions, beyond just the Puget Sound, which is where I'm from. Today, as you can see here, Pantograph in any given week tracks about 15,000 different vehicles on 2,600 routes from 69 agencies in the 11 regions that I support today, with more regions and more agencies constantly in the works. At the time, you know, because I was trying to just learn things, but now I'm creating an actual app. And the way that I view my audience based on who my audience is we have about half and half people who are just normal everyday riders, people just trying to use the system to get to where they're going, and about half people who have some deeper level of understanding from the system. Those might be transit geeks. I will always be my first audience. That might be operations teams. I know people that work in a variety of roles within transit agencies, operations and related roles that use my application because it is simply easier to use or better or more accurate or what have you than their own internal tools. Lots of rider informations folks use my application as well. People who proactively communicate with riders regarding service interruptions, or who maybe reactively interface like through phone calls and such, information about their services. So I kind of view my responsibility as trying to provide two opposite ends of the spectrum: high level system performance information and low level operations details, trying to access a little bit more information than maybe your typical quote unquote transit app would give you in terms of strictly arrival information or trip planning. That said, I do have arrival information. I just added that to the iOS app. But before we keep going, I want to jump over to the application itself and spend just a couple minutes looking at it so we all kind of have a shared understanding of what Pantograph is. And then we'll go into how it works. So you should be seeing the main website here now. We've got all the, let me adjust the screen area here or not. Okay, that'll work. This has got all the main regions that are supported here. We can jump over. I'm going to go over to the Bay Area to start with. And this shows every single transit vehicle across, I think, about 20 different agencies in the Bay Area currently in operation. And so, you know, we can zoom in here. We can click on one of these. We can see that this is a 96 going over the Diamond District. It's a 2016 Gillig. We can click on block information here to see all of the trips that are in this vehicle's current block, as well as open up trip information to see its schedule and real-time arrival estimates for its upcoming stops. And we can hover over those to see how that compares to schedule. It looks like it's running slightly ahead right now. And we can do this for every single vehicle. We've got Muni over here. We can go down south. We got VTA. This green bar shows loading information for agencies that provide real-time passenger loading, which I'm hoping is going to become more and more of a thing in the future, especially now that we're 2 years into a pandemic that doesn't want to go away. And this is sort of the main feature of the app. We can go over to DC. We got all these vehicles for WMATA, the Circulator, Arlington, Fairfax, MTA, Maryland. We can go over to the New England area, which has been very interesting to watch this weekend with the blizzard coming through. I know Mark was in this room earlier. RIPTA was entirely shut down yesterday. The MBTA has managed to mostly maintain service. And of course, we can go over to the list view and view all of this information as a list rather than as a map as well. We also have a fair number of controls over here to control things like what information is appearing on these bus icons. Like we could show maybe the short 4-letter head sign, maybe color it by timeliness to see where all of the late vehicles are. We can control which vehicles we're actually showing on the map, which can be helpful to only view a subset of vehicles at a time. Lots of utility in here in terms of what we're looking at on the map and what kinds of information is available to us. We can also see a list of all of the routes. I'm actually going to jump over to Puget Sound for this one, just because this is an area that I'm a little more familiar with, simply by nature of this being my home region. So just for posterity, here's what the bus situation looks like around here right now. But we can jump over to routes. We can see a list of the routes here. I'm going to choose the 45 just because that is a King County Metro route that I'm somewhat familiar with. I used to live right along it. It's near the university. And we can see here some basic information about the route, where it goes, what kind of service it is. We can see a full list of vehicles that have served this route, or that Pantograph has seen serving this route specifically, as well as some basic information about the kinds of vehicles that serve this route, essentially a summary of this information. Pantograph flags what it calls anomalies, excuse me, which refer to essentially unusual assignments. In this case, it looks like those are probably 40-footers because this route usually gets articulated buses on it. But it also looks at things like the King County Metro rapid ride routes, for instance, which are sort of BRT routes. Those use a special fleet of buses, and if for some reason a rapid ride branded bus ends up on another route or vice versa, Pantograph will recognize that that's not supposed to happen and flag that as an anomaly in real time too. Let's see if we've got any of those out on the map today. Not at the moment, not that rapid ride example specifically, but we do see here like some XDE 60s on the 7. Pantograph will also compare model and size assignments, so we don't usually get the XDE 60s on this particular route. And we can also view this information for vehicles as well. Just like we were looking at route history, we can jump over and see vehicle history. So I'll pick on CT here. We can jump over to any particular bus. We can see the list of trips that this coach has served. This is one of the double deckers. Last out and about a couple days ago on the 413. All the different kinds of routes that it's been assigned to. And we can go in and say, well, show me everything for all vehicles in that series as well. These aren't out and about right now because they only get used on weekdays. But because Pantograph records all of the trips that it's seen in service, and because it consumes full schedule information, we can kind of compare these two to see, okay, well, which trips didn't get served? What did I see? What was supposed to be served? And therefore, what was probably missed? I say probably because, as we'll get into momentarily, real-time feeds are only so precise, so it's more of an approximation. And the definition of a missed trip can also change a lot between agencies. Most of what you're seeing here for King County Metro represents pre-planned canceled trips that they're not running right now due to the nationwide operator shortage. But because their schedule feed still declares those trips as running, they're going to show up as missed because they did not appear in the real-time feed. Different agencies do different levels of precision here, but it's something that's important to keep in mind that this is an approximation, but it's also very interesting information to look at, especially comparing the day-to-day. You know, if we look at any given Tuesday in the last week, you know, they ran about 90% of their trips according to the real-time feed. And on the following Wednesday, if I pick my dates right, okay, there's a slightly more stark example, but that was a little bit different on that Tuesday versus that Wednesday. Other dates will have a little bit more strong variation, but as you can see here, we can also jump through and see how this varies across routes as well. I've been showing you the web version. Pantograph is also available on the iOS app, which you should be seeing now. This is still the Puget Sound. All the same features are available between the two, with the exception of real-time stop departure estimates. I just rewrote the whole web version. I wasn't quite able to sneak this in at the same time, but it is coming soon. So we can see here a list of stops that are nearby to me. We could also search for some stops, and we can open up and see a departure board with real-time estimates as well. And we can even zoom out and see where these upcoming buses are at the moment. And we can do this for any stop in the system, really. So that is what the apps look like. I'm going to go back over to my slides now. Here we are. And talk about the source data that's powering all of this, the way that all of this works. The schedule information comes from something called the GTFS, the General Transit Feed Specification. This is the primary means of communicating, that agencies have to communicate their scheduled service out to riders. This is very strictly scheduled information. This might be updated maybe every few weeks, or even more often every few months at a regular service change, kind of depends on the agency. It's been around since 2006. It was actually originally called the Google Transit Feed Specification because they helped develop it, but that was since changed to general, and it's now an open collaborative standard that is maintained and evolved by the community. We can essentially think of this as a relational database distributed as just a bunch of text files as CSVs through a zip file. But it defines a transit system by its stops, its routes, and its trips. Stops, routes, and trips are essentially the core of a GTFS feed. And then from there, once you've declared the existence of a route and a bunch of stops and the existence of a trip, you can then go in and say, well, that trip that I've said exists is going to serve stops A, B, and C at times X, Y, and Z. And that essentially puts together a whole transit feed. The additional information can be communicated through this feed as well. Things like blocking information. For those who don't know, blocks refer to a set of trips that an individual vehicle is set to run throughout the day. And so often blocks will be communicated through the GTFS as well, so that we can see what trip a vehicle is expected to continue on to. Sometimes that might refer to an NC transfer, sometimes it might not. But it can be helpful, particularly in real-time applications, to know what trips are upcoming for a certain vehicle. So to that end, GTFS has an extension called GTFS RealTime, which is designed to, in real time, update the GTFS and say, okay, that trip ID that I've said exists, this is an example from the King County Metro feeds, is now going to serve whatever stop at this whatever time. It looks like this one is a little over 2 minutes delayed for it as an example. And GTFS RealTime is distributed as 3 separate feeds, one of which is service alerts, which we're not going to jump into today, but it's pretty self-explanatory. That's where service alerts are communicated. Vehicle positions and trip updates. And I've got samples of little snippets of those here on the slide representing the same trip in those 2 separate feeds. Most transit apps that we communicate with on a regular basis are using this trip updates feed to provide the real-time arrival estimates at a given stop and to do trip planning based on real-time information on where the buses are or are not if that trip happens to be marked as canceled in the real-time feed. Pantograph makes a little bit heavier use of the vehicle positions feed as well, considering that's sort of the main purpose of the application is, of course, that real-time map. And this is where we get to see where all of those vehicles even are to begin with. All of this stuff, everything with transit data is not without its challenges. Some common challenges that I find myself facing, feed quality integrity is a big one. There are plenty of feeds out there that simply aren't structurally sound or don't reference themselves properly. So one of my first tasks when going in and adding an agency, once I can find their feed, is opening it up and making sure that everything appears to just make sense and validates properly. Similarly, jumping ahead on the list here, feed availability is a big one as well. A lot of agencies may have a real-time feed available, but good luck finding it. They don't necessarily communicate that as clearly and openly as might be desired. So something that I've learned over time is learning how to recognize some of the common vendors that agencies use for these solutions and knowing what their URL structures are like and how to then go in and access the real-time feed that way. Another item here is string presentation. I'm not naming names on any agencies here, but here are some stops that are presented in all caps in the real-time feed. And as a user of an application, that's not a particularly desirable experience. You don't want to get on Westerly Town Hall. You want to get out of Westerly Town Hall. So I put a lot of work through my application into correcting all caps names, particularly for stops, but also for head signs, which we'll get to in a moment here. And that is unfortunately not as easy as it sounds, because how do you know that as a computer that ROW is the word row and not maybe an abbreviation of the, I'm not going to make up an abbreviation for that off the top of my head, but discerning those abbreviations from words. I put a lot of time into that. We also end up with messy data sometimes. Here are some trip head sign values for, I think this is a different agency. No, it's the same agency. This one should just say Mohawk to Mohawk Marketplace. See earlier conversation on head signs for vehicles, but they've included the route name in there. This is the Route 18, and it looks like this is some sort of copy paste from the software that they're using to manage the actual head signs on the buses. So we end up with a symbol in here that's not actually useful to a rider. So what this would read as presented is the Route 18 Mohawk to bracket 18 Mohawk Mukuplet, which is, again, undesirable. So I have put a lot of work into cleaning up a lot of this kind of information for this agency specifically, but also generally for agencies that produce similar kinds of artifacting. I'm shaming a few here, but this is very common examples of things that tend to happen. Starting to run out of time here. I want to make sure we have time for questions. So I'll also acknowledge unreliability. Sometimes feeds just go down sometimes, and then there's not a lot that I can do about that. And that is really unfortunate for riders too. If they're supposed to know in real time where a vehicle is going to be, and now that information just isn't there, that is a frustrating experience as a rider. And there's actually one agency who, again, I'm not going to name, that sometimes when their feed goes down, it just goes down entirely. But other times it just brings in interpolated information from where the buses should be based on the schedule. So it shows that everything is on time according to the real-time feed, and that all the buses are exactly where they're supposed to be. And that's worse. That's worse than showing nothing, because now the feed is lying to you instead of just not giving you information. So that is also a pretty frustrating thing that happens. Lots of other items that I'm not going to get into at this time. But some final thoughts that I want to leave you with are that open data matters so much. This is the very beginning of everything that powers all of our rider applications, whether it's Pantograph, whether it's Google Maps, whether it's Transit app. They all come from the same place. And therefore, it is really important for transit agencies to be producing data that is reliable, data that is accurate, data that is consistent, and really represents the state of the system. Open data is also a fantastic source for insight and analysis when it is reliable. So like we were looking at the missed trips earlier, when the schedule feed is an accurate representation of what trips are supposed to be running, and the real-time feed is really robust and has high uptime and that sort of thing, we can get a really accurate picture for what trips are being missed. And that's before we even get into using these feeds for performance analysis. I'm only storing individual vehicle and trip associations, but if I stored every single GPS ping from every single vehicle and how far behind it was at that time, we have some fantastic data there when it comes to where delays start to accrue and that kind of thing. And lastly, open data feeds can also be the building blocks of innovation, because when we make more data available in an open capacity that is freely available to anyone, anybody can go in there and start playing with it and utilize that data in ways that I'm not even thinking of and that we're not even thinking of yet. But again, all this depends on really robust, reliable information being provided by the agencies. I've included a picture here that I took of the infamously unreliable Sound Transit Link Light Rail real-time arrival signs that they are working on addressing with a brand new system coming, I believe, later this year. But when the data isn't there, it's just not useful. So that is it from me. I want to make sure we have a couple minutes here for questions, and it looks like we're coming up on our transition time as well. I encourage you all you can find me on Twitter, you can find the application on Twitter. These are those URLs again to access the app itself, as well as download it onto the iPhone, and you can email me directly here. But once again, thank you all for being here. I appreciate it.